Make sure you don't have a calculator in front of you.
I don't. Sorry, I'm always getting confused by that. Is that a -2 minus 2?
Yes.
Okay, so then that would be -4.
Okay, cool. Do them as fast as you can.
I'm trying.
I know. I'd like to see you speed up a little bit. In other words, what's going to allow you to speed up?
-32.
Yeah, what's going to allow you to speed up is learning them. Once you learn them and you have them stored in your memory, you won't take long.
-10.
Whoops. What is it?
-10. Or -2.
Well, take your answer you got, multiply it by the divisor. That would give you 100. So it can't be -10.
Oh, yeah. Sorry.
Okay. In other words, the way you always check your answer here is by multiplying your answer by the divisor. If -2 times -10 is equal to 20, you've got it right. And it is. Always remember that division is just the inverse of multiplication.
-20. 5. 10.
Take a guess.
11?
Yeah. It's not 10, right? And it's not 12.
Yeah.
One good thing to remember is that 12 times 12 is 144. So it's got to be between 10 and 12, and we know it's a whole number, so it has to be 11.
-8. 15.
You're definitely getting better.
-9. -5.
Remember your rule of nines. What's the first digit have to be?
It has to be 3.
Hold on. First digit's always one less than that number, 6.
Oh, 5.
I mean, if you were multiplying it by 7, then the
54.
would be 6. But the first digit is always one less than that number.
So 54.
Yeah, and then the second digit has to add to 9 with that number. So that's the easiest way to do those, is to use the rule of 9.
-1.
Good. I really like your improvement on positive and negative numbers, because when we started
54.
out, you were not good on your combination of positive and negative numbers.
-6.
You are now. You've got it down for sure.
5.
All right. I don't think we need to do that anymore. What kind of stuff are you working on in class?
System of linear equations.
Okay. You have some you can read?
Yeah. X equals 17 minus 4y, and then the second one is y equals x minus 2.
X equal, I'm sorry, I wasn't ready to write when we were talking.
X equals 17 minus 4y, and then the second one is y equals x minus 2.
Okay. Now, presumably you've learned the substitution method. Have you also learned the elimination method, or just substitution?
Just substitution. We just started working on this today.
Okay. So what's the next step?
Well, you have to get... The thing is, when she did this, we were doing like nothing like these equations in class. We were doing other like different ones.
Here's the way you want to do the substitution method. You want to take the equation that's fully solved for one variable, which is actually either one, right? And substitute it for that variable in your other equation.
Yeah, so it would be y equals 17 minus 4y minus 2.
Make sure you put parentheses around it just for clarification, okay? Sometimes you need those parentheses, sometimes you don't. For example, let's do it the other way. Let's substitute x minus 2 for y. So that would give us x equals 17 minus 4 times x minus 2.
8.
Now, in that case, I need the parentheses. I can't get by without them. The way you did it, I didn't actually need the parentheses. Sometimes you do, sometimes you don't. So I always put them in there just for clarification. What's the next step? If we do it my way, what's the next step?
Then the next step is to do like terms. Not like terms, sorry. I always forget the word, but you have to multiply for negative 4 times x minus 2.
Doesn't matter if you remember the word. If you can read the next line to me, that's all that matters.
So it would be x equals 17 minus negative 4x minus...
Hold on, be careful.
Plus 8.
Okay, but it's not minus a negative 4x. It's minus 4x plus 8.
Yeah, I said minus.
That whole thing becomes just one minus. Originally you said minus a minus 4x. Which would have turned it plus, which wouldn't be correct. Okay, now what's the next step?
You have to add like terms.
Okay. Which
So
side?
it would be,
the question you always have to answer yourself is which side are you going to put the variables on?
the left because...
Okay. So what?
Yes.
How do I get all the
Add
variables
4x.
on the left side?
Add 4x.
Okay. So that, what's that give me on the left?
5x.
And what am I left with on the right?
5x equals 25.
Okay. Now how come that took you a while? You were adding those two numbers. If we were doing that A plus math, you would have gotten that in about 2 seconds.
Because it was... Because I haven't memorized.
I'm not sure what the answer is. I think it's just that in one mode you're really good at it, but if you make them horizontal instead of vertical, it throws you off a little bit. So let's work on that. Let's work on making sure that that is the same problem as this, and you get it just as quick. Okay? What else you got?
6x.
Let's back up one. In other words, is all we did was solve for x, right?
Yeah.
Well.
Oh yeah, and then we have to place it into the other equation.
Which one?
Since we substituted it for the x equals 17, then we're going to place it back into y equals x minus 2.
You could actually put it in either equation if you want.
I want to put it into
actually substitute it into this equation and say 5 equals 17 minus 4y and solve that. But the second one is actually the easier one by a lot.
Yeah, because
y equals 3.
Yeah.
With very little calculation. So the one you want to substitute it in for is the easiest equation you're looking at. And clearly that's an easier equation than that. All right, what else you got?
So wouldn't the points be 3, 5?
Yes.
Okay.
Well, 5, 3.
Oh, yeah, sorry, I always get those.
X was 5, Y was 3.
Okay, so 6x minus 9 equals y.
Okay.
Y equals negative 3x.
All right. Now this is kind of a special substitution type problem. You don't, I would say you do get these occasionally. If this is equal to y and this is equal to y, and it's the same y, in other words, this is a system of equations, meaning it's the same y and the same x, as opposed to just being two separate functions. But because y is the same y, what can I write? If I got y equals a and y equals b, what can you say?
Y equals a plus b.
No? If I tell you that y equals a, and at the same time y equals b, well, what else?
Then a and b are correct.
A is equal to b. Not that they're correct, sorry, but that a equals b.
Sorry.
Right. So what can I say in this problem?
6x minus 9 is equal to negative 3x.
Yeah. So we got 6x minus 9 equals minus 3x. Next line.
6x equals negative 3x plus 9.
Okay. Can you do both steps at once? In other words, yeah. This is the one case where I really think it makes sense to do both steps at once. Because what you're doing is you're gathering everything with an x in it on the left side, and you're putting everything else on the right. So let's just do it all together.
So 9x equals 9.
There you go. X equals 1. What does y equal?
Y equals 1, right?
X equals 1. In other words, we got the solution for x, but now we have to solve for y. What's y?
So then it's going to be y equals negative 3 times 1. So y equals negative 3.
Yeah, and that point, if they want x and y coordinates, it would be that point there. Okay, what else?
2x equals 12. And then x minus 5y equals negative 29.
Now notice here that neither equation is completely solved for a variable.
Yeah.
But we can easily take care of that problem by doing what on the first equation?
By dividing it by 2, dividing 12 by 2.
So really, now we have that, and now everything that is fully solved for one of the variables.
Yeah.
Now what?
So it's going to be 6 minus 5y equals negative 29.
Okay. Now
and then it's going to be negative 5y equals negative 35.
Okay.
And then it's going to be 7y equals 7.
Right. Now, let's back up one step. It's not a big thing, not a real important thing, but I just want to mention it. If you're using the rule where you always want the variable to have a positive coefficient, then I'm going to move the 5y to the right side and move the minus 29 to the left. And that's going to give me 5y equals 35. Notice no negative numbers. Same answer. So it's not a major thing, but whenever you're making this decision as to which side to move your variables to, consider that. In other words, move the variable to whichever side is going to give it a positive coefficient, not a negative one. And frequently, you'll turn a problem that would have had two negative signs into a problem that everything's positive. So what's x equal to if y equals 7?
2 times, 7 minus 5 times, I mean,
Okay, don't
X.
overlook the obvious. What's x
X,
equal to?
X equals 5,
Hold on.
X minus 5.
Look what I just circled. What's x equal to?
6, oops.
Yeah, in other words, we got that from that equation right there. So in other words, x was already solved for. We didn't really need to go back and do any work on x. You know what I'm saying? I mean,
Yeah.
we could have gone back to the original equation and substituted. No, we couldn't have, because there's no y in that original equation. If you wanted to do it the hard way, you'd substitute y of 7 into that, and you would still get x equals 6. But why do all of that work? In other words, if x is already solved, take it. Anything to speed stuff up you want to do. What else?
2x minus y equals 23. X minus 9 equals negative 1.
Equals what?
Negative 1.
Okay.
So it's going to be...
And it was x minus 9, right? Not x minus y? Okay.
No, it's x minus 9. So it's going to be... 1 second.
If you're going to use substitution, then you're going to have to solve one of these equations for a variable. You can't really use substitution until you get it so that x equals something.
X equals 8.
Now you can use substitution.
2 times 8 minus y equals 23. 16 minus y equals 23.
Now what?
Y equals 7. And then x equals 8.
Hold on. Y does not equal 7. Notice 16 minus 7 does not equal 23.
Oh.
Tell me how you did it. Give me the next line. Because that's, if you're making a mistake, I want to know where you're doing it. Here's what I suspect you did. 23 minus 16, right? And then you just drop the negative sign.
Yeah.
That's partly why you don't want negative signs in front of your variables. Notice that if I do it the way I was describing, I'm automatically going to move the y to the right because that gives it a positive coefficient. Which means I got to move the 23 to the left. 16 minus 23 is minus 7. Done. One step.
So it's going to be 8, negative 7.
Yes.
Five x plus 2y equals 9. X plus y equals negative 3.
X plus y?
Yeah.
Okay.
So it's going to be...
Yeah, what's your first step going to be?
To solve for one of the variables.
Which one and which equation?
I think I'm going to do the bottom one because
that's the easier one. It's got all the small numbers in it. Always pick those if you have a choice.
So x equals negative 3 minus y.
Okay, now what?
Then is that done with that equation?
Well, no, now we have to substitute. In other words, wherever we see x,
sorry, that's what I meant.
we're going to substitute that. And
that's
it
what I
has
meant.
to be in the other equation. Notice that if we substitute it in the same exact equation, everything goes to 0 and you get 0 equals 0. You don't solve for anything. So you're going to have to substitute this expression into the first equation.
5, and then in parentheses, negative 3 minus y plus 2y equals 9.
Okay. What now?
Negative 15 minus 5y plus 2y equals 9.
And what else?
And then it's going to be negative 20, sorry.
I don't know why my computer does that. I can't imagine why Windows 10 would have that happen. Every time you get your cursor anywhere near it, pops open those windows. So what do we got now?
So it's going to be 3y equals 24. Negative 3y.
And negative 3y.
Yeah.
Okay, so what's y equal?
Y equals negative
when you know the answer is a whole number,
8. Negative 8.
you've always had trouble with that one. 3 times 8. Every time that's ever popped up on A plus math, it takes you a little bit while longer to do it. Okay. And of course, we'd have to still solve for x. Well, go to the one that is the easiest to solve for x, which is that one right there, right?
Yeah, and then you replace negative y minus plus 8, so x equals negative 3 plus 8.
Good.
X equals 5.
Good. Now, you're doing pretty good on these. Let me get you ahead of the curve a little bit. And by that, I mean, I'm going to give you a different problem. And I'm going to give you the elimination method, which you're going to learn tomorrow. I'm going to change this problem just slightly. Okay? Let's say those were our two equations. When you have equations, you are always allowed to add any two equations. In other words, if I have a plus b equals c and x plus y equals z, I can add those two equations such that a plus b plus x plus y equals c plus z. You can also subtract any two equations. So I could say a plus b minus the quantity x plus y equals c minus z. With me?
Yeah.
It's going to make these problems so much easier. Add those two equations.
Wait, repeat that.
Add the two equations.
5x plus 2y
Hold on.
plus x.
The way you add these two
sorry.
equations is to add the x's,
6x.
add y's.
6x plus y, nothing. 0,
That's the key. That's why it's called elimination. Equals what?
Equals
Got to add the two numbers. Right.
6.
Notice how much easier that is.
Mm-hmm.
Now, once you solve for x, you have to go back in and in any of the equations, substitute 1 for x, and you'll be able to solve for y. Okay? But elimination is super powerful when you're given both equations in standard format. Okay? What makes that standard format is I have the x's and y's on the left side of the equation, the number on the right, in both equations. So when you're in standard format, always consider elimination because it works so much better than substitution. Substitution's a pain in the butt when you discover elimination. Okay? No pun intended. Now let's change the problem to this again. Now, notice,
do you want me to add them?
If I add or subtract, I do not eliminate a variable, right? But what if I take equation number 2 and multiply both sides by 2? Then what does it become?
2x minus 2y equals -6.
Now we have a new equation 2 that I can add to equation 1 and eliminate a variable.
7x equals 3.
See how powerful that is?
Yeah.
So always remember that you can either add or subtract. Let's say that this is the problem. Let's say these are my 2 equations right here. Okay? Well, I cannot eliminate a variable by adding. I get 7x plus 4y. The idea is you have to eliminate a variable. Well, I subtract these two. What do you get when you subtract?
3x equals 15.
X equals?
X equals 5.
Yeah. Now, to figure out y, I would go into the simplest equation on the page, which is that one, and substitute 5 for x. So now I have 10 plus 2y equals minus 6. 2y equals minus 16, y equals minus 8. X equals 5. Okay? So it's a terrific method to use as long as you can easily, let me give you one more and then I'll let you go. What are you going to do here?
I am going to...
Remember what the goal is. The goal is to eliminate a variable.
Multiply.
Which by what?
The bottom one by... I don't know, actually.
Well, I think you're on the right track. You could multiply the bottom one by 1.5, and that would turn this into a 3x, right? But then I'm introducing fractions and decimals, and I don't want that. So how about we do this? We multiply the top by 3, both sides, and we multiply the bottom by 2, both sides. Notice now what our new equations are. We got 9x minus 6y equals 30. And at the bottom, we got 4x plus 6y equals 10. Now we have two equations that we can work with. In other words, now I can add the two equations and I get 13x equals 40. So I can solve for x. Okay? So sometimes you have to do that. Even when they're both in standard format, if you cannot easily eliminate a variable, you kind of have to find the least common denominator. It's a least common denominator type process to multiply both equations by so that the variables will have the same coefficients. Notice that by multiplying the top by 3 and the bottom by 2, I ended up with a 6 in front of the y in both cases. You know how to get rid of this little picture here? Do you see it?
Yeah, you move over to a different icon. One that you don't have a tab open.
Ah, okay. So that's all I have to do. In other words, when it pops up, if I move to a different, if I move to a different icon,
that you're not open. That you don't have. That you don't have open.
Ah, that you don't have open. So I got to go to something like my Internet Explorer, which I never use. Okay, thank you. That'll be helpful because sometimes that thing pops up and then I can't write on my drawing tablet.
Yeah.
So, Logan, you're doing pretty good. I like the progress I'm seeing. What are you getting in the class, grade-wise?
I have a really high B.
Good for you. Good for you. Your math skills have improved and clearly you're understanding the stuff you learned so far. Terrific. Logan, I'll talk to you next Tuesday.
Okay.
All right. Bye-bye.